Alright, so for this lesson, we'll be discussing or looking into the CAS diagram, right? So the CAS diagram involves things like reduction formulas and co-functions. Alright, but what is the CAS diagram for? What is it used for? It is actually a mathematical tool. It is a tool that we use in trigonometry. But I want to start our discussion here. Trigonometry. On the previous videos I did define what trigonometry is all about. So trigonometry is basically the study of the relationship between angles and sides in triangles. It's important I start here, right? I want to give a bigger picture before we go forward and start solving reduction formulas and co-functions and working with them. So trigonometry is basically what? The relationship between angles and sides in triangles, not in triangles, right? So if I draw a triangle like this angle, this angle, and this angle, right? But keep in mind, here I just drew a right angled triangle, a right angled triangle. Okay, so all the angles in any given triangle, they are all what? Acute. They are all acute. They are all acute angles. Acute, right? So trigonometry basically, at its core, it deals with acute angles. But there comes a time where you find yourself working with angles that are bigger than 90 degrees. So the CAS diagram, it exists for that purpose, to work with angles that are bigger than 90 degrees. So in other words, the CAS diagram allows us to work with angles that are obtuse and reflex, right? So yeah, now the CAS diagram, this is the CAS diagram, right? The CAS diagram tells us that so the CAS diagram is basically a Cartesian plane divided into 4 quadrants. We label this the first quad, this quarter the second quad, this quarter the third quad, and this one the fourth quadrant. So they are labeled anti-clockwise. You can see that, right? And then the cardinal points, or the north, south, east, and west parts of the Cartesian plane, have the angles 0 degrees, 90 degrees. So you can see that the angles, they're increasing in a anti-clockwise direction. So we start with 0 on the east side, and then 90 degrees on the north side, and then we have 180 on the west side, and then 270 on the south side, and then 360 back to the east side of the Cartesian plane. And then the CAS diagram also tells us that in the fourth quadrant, cos is positive, then the rest is negative. In the first quadrant, all of the ratios are positive. All of them are positive. But in the second, only sign is positive. And then for the third quadrant, only tan is positive, then the rest is negative. Okay, so the first set of formulas that we're gonna study here or discuss, it's this one called the reduction formula. Okay, so we use the reduction formulas for reducing angles that are above 90 degrees. So your obtuse angles, What is an obtuse angle? An obtuse angle is basically any angle that is bigger than 90 degrees but less than 180. And then we also have a reflex angle that is bigger than 180 but less than 360. I hope I got this right. But yeah, so any angle that is bigger than 90 degrees, in essence, any angle that is bigger than 90 degrees is reduced using reduction formulas. So let's talk about these formulas for a moment. So these are the formulas. We have one in the second quadrant, which is 180 minus. We also have another one in the third quadrant. This is 180 plus. And then in the fourth quadrant, we also have a third one, the 360 minus theta. Okay, so the theta is usually a, let me use a red marker here. So these are the reduction formulas. And then the angle theta, these angles are acute angles. And as you'll see in some of our, in one of the examples we'll be doing, in fact most of the examples we'll be doing, all the angles that are bigger than 90 degrees that we will be reducing using reduction formulas. These acute angles are going to end up being special angles, right? That's not always going to be the case, but for most of the problems we'll be solving, whether in an exam, in a test, you're going to reduce your acute angles, your reflex angles as well as your obtuse angles back to special angles. Okay, so let me show you how to deal with these formulas. Okay, so sine 180 degrees minus theta. We also have a cos 180 degrees minus theta, a tan 180 minus theta. Let's also work in the, I don't know, yes, third quadrant. So we also have a sine 180 plus theta, a cos 180 degrees plus theta. We also have a tan 180 plus theta. Fourth quad, come on. 360 minus theta, a cos 360 minus theta, and then a tan 360 minus theta. Okay, 360 minus theta. These are formulas, right? These are formulas. You need to learn how to solve them, right? You need to learn how to solve them. So 180 degrees minus theta, where is this found? It's found where? In the second quadrant. And we know that in the second quadrant, sine is what? Sine is positive. So solving this formula, right? Solving this formula with the sine ratio, it's going to be positive sine theta. Why positive? Let's go back to the logic we had initially. So we first start off by identifying where 180 degree minus theta is located. Oh, it's in the first quadrant. The 180 minus theta formula is in the second quadrant. Since it's attached to sine is located, sine in that quadrant is what? Is positive. So our answer is going to be a positive what? Sine theta. Don't worry, it's all going to make sense the moment we start solving problems. Just for now, I'm just showing you how to work with these formulas. So we have a cos 180 minus theta. 180 minus theta, again, it's in the second quadrant, and in the second quadrant, cos is what? Is negative. There's only one ratio that is positive, which is sine. So again, 180 minus theta is located where? In the second quad, right? And in the second quad, tan is what? Is negative. So it's going to be a minus tan theta. All right, now for the third quadrant formula, the 180 plus theta, right? 180 plus theta, sine is what? In the third quadrant, sine is negative, so it's going to be a negative sine theta. Going for the second one, 180 plus is located where? In the third quadrant, and in the third quadrant, cosine is what? Is negative, so it's going to be a negative cos. 180 plus, again, it's in the third quadrant. Tan is what? Is positive, so it's going to be a positive tan theta. Now for the last reduction formula in the fourth quadrant, this one right here, sine is what? Is negative, so it's going to be a negative sine theta. Cos is positive, so it's going to be a plus cos theta. Tan 360 minus is located where? In the third quadrant again. So tan is what? Is negative, so it's going to be a negative tan theta. So this is how you go about solving your reduction formulas. Okay, keep in mind the reduction formulas are used for what? Reducing reflex and obtuse angles to acute angles, right? And normally, after doing reduction, right, after reducing those angles, the acute angles you're gonna end up with are gonna be special angles. Okay, so let's take this down and take some examples. Okay, so I have sine 315. What type of angle is this? Reflex angle, right? Let me label it as R. 120. What type of angle is this? Obtuse. 330, another reflex angle, right? Cos 225. What's this? Reflex. Another reflex, and an obtuse angle, right? So we're gonna reduce these angles to acute angles. Yes, to acute angles. Or let me just say these are examples that we have to solve without using a calculator. All right, there's a video that I've done for special angles. Okay, so check the description box for that video. Just go through it and understand the whole idea with special angles, right? So we are solving without using a calculator, so it means that you have to do some arithmetic on these angles so that you can have what? Special angles. So should I? Okay, yeah. Let's put the special, the reduction formulas. So this is something you should know. You should know by heart, right? So you should know that in the second quad, I have a reduction formula which is 180 minus theta. In the third, it's 180 plus theta. In the fourth, it's 360 minus theta. Okay, minus theta. So let's solve these ones. Okay, so 315. Where is 315 located? Where do we find 315? So the first thing you have to do is ask yourself, where is the given angle, whether reflex or obtuse, where is it found? First, second, third, or fourth? But I can see that 315 is found where? In the fourth quadrant, because 315 is between 270 and 360. So it means that I'm gonna use the 360 minus theta formula. So it's gonna be sine open bracket, meaning that the 315 I have to write it as 360 minus some angle. Let me show you. Let me pull out a calculator here. Yes, come on. So it's 315 minus 360. It's 45. So it means that this 315, you should write it as the formula of 360 minus some angle. What is that angle? 45. So it's going to be 360 minus 45 degrees, right? So 360 minus 45, it's what? It's 315. This is what I mean by you have to write this as a reduction formula. Then you solve. Sine 360 minus theta. Where is this located? Fourth quadrant. So the 360 minus 45, it's in the fourth quadrant. And sine is what? Is negative in the fourth quadrant. So it's going to be minus sine 45 degrees. Okay? Minus sine 45 degrees. Yes? Minus sine 45 degrees. As you can see, we just reduced the 315 to 45 using a reduction formula. Now you can solve the 315 without the calculator if you have it as a, or expressed as a special angle. Now I'm going to bring in the triangles. 45 degrees. Here it's 1 square root what? 2. Square root 2. We also have the other one, the other triangle, this one, the 30 60 triangle. It's gonna be 90 30, it's 1, then 60 degrees, it's square root of 3, then we have a 2 here. Okay, so this simplified, it's gonna be equal to I'm not sure if you can see this, but let me just write it here. So it's going to be a minus sine 45 using SOHCAHTOA. So we can use this 45 here, or even this one. You're going to get the same answer. So we're using this triangle to simplify that. So sine 45, it's what? According to SOHCAHTOA, sine 45, sine, it's opposite over hypotenuse. It's opposite over hypotenuse. So it's going to be a minus opposite, which is 1, hypotenuse, square root 2. Okay, square root 2. Now for the second one. So for the second one, it's going to be sine, open bracket, 120. Where is it found? It's found in the second quadrant, because 120 is between 180 and 90. So I'm gonna say 180, this 180 minus 120, then I'm gonna get the theta. In this case, it's what? It's 60 degrees. So I'm gonna write it as 180 minus 60 degrees. So 120 can be written as 180 minus 60. 180 minus 60 gives us what? 120. So this simplified, it's going to be a positive sine 60 degrees. Now using this triangle to simplify that to a value, it's going to be what? So sine 60 degrees, 60 using SOHCAHTOA, it's opposite over hypotenuse. So the answer is square root 3 over what? 2. Sine 330. 330, where is this located? Where is 330 found? In the fourth quadrant, because it's between 270 and 360. So sine, open bracket, it's gonna be, we wanna write the 330 as a reduction formula, right? So it's gonna be 360 minus 330. Answer 30 degrees. So it's 360 minus 30. 330 has been written as a reduction formula to 360 minus 30. This is equal to sine in the fourth quadrant is negative, so it's going to be sine, negative sine 30 degrees equal to, so 30 degrees SOHCAHTOA, sine its opposite over hypotenuse. So the sine, 30 degrees being a reference angle, this being the opposite side, and this being the hypotenuse. So it's going to be a half, and negative 1 over 2. Going for this one, it's going to be what? It's going to be a cos, open bracket, 225. It's where? It's in the third quadrant because it's between 270 and 180, right? So 180 minus 225. Minus 225, it's 45 degrees. So I'm going to do this now. I'm going to write it as 180 plus 45 degrees. 180 plus gives us what? 225 equal to, let's solve. Cos is negative in the third quadrant, so it's going to be minus cos 45 degrees. Okay, so cos 240, where's 240 found? 240 is again in the third quadrant, right? So it's going to be a cos, open bracket, 180 plus, right? But let's get this acute angle. So it's 180 minus 240, it's 60. So it's 60 degrees equal to, okay, we're going to come back to this one. So it's going to be a minus cos 60 degrees. So using the 45 triangle, this is going to be a minus 1 over square root 2. This one is going to be a minus cos 60. It's going to be a minus square root 3 over 2 using this triangle and applying SOHCAHTOA on that one. So 240 again, it's going to be a tan 180 plus 60 degrees. It's 240. So the reduction formula should be the same. And then tan in the third quadrant is what? Is positive. So it's going to be a plus tan 60 degrees. Now looking at this triangle, applying SOHCAHTOA, it's tan opposite over adjacent. So 60 is the reference angle. It's opposite over hypotenuse. This is the hypotenuse. So it's what? Square root 3 over 2 tan 135. It's between 180 and 90. So we're going to apply this formula, 180 minus. So it's going to be 180 minus what? 45. Because when you take the difference between this and this, it's going to be 45 equal to, in the second quadrant, tan is negative. So it's negative tan 45 degrees equal to minus 45 degree triangle, this one. So whether you look at this as your reference or this as your reference, it doesn't matter. So applying SOHCAHTOA for tan 45, it's opposite over adjacent. So it's going to be minus 1 over 1, which is basically minus 1. So this is our answer. So this is how you deal with reduction formulas. Okay, and there's three reduction formulas. One in the second quad, another one in the third quad, another one in the fourth quadrant. Okay, so I'm taking this down. I want us to discuss the second part, which is co-function or co-ratios. Okay, co-functions or co-ratios. So what are co-ratios or co-functions? Co-functions, you know what, I'm gonna try to explain this using a visual, right, or using a graph rather. So there's two co-functions, two formulas for co-functions. It's 90 degrees minus theta, first quadrant, and a 90 degree plus theta in the second quadrant. There's only two co-ratios or co-functions, right? And by definition, they only apply to sine and cos. Nah, I think I'm lying. They also apply to the tangent as well. But we're not gonna get into that one yet, right? Yet. So I have a sine 90 degrees minus theta, a cos 90 degrees. Let me separate them. And then we also have a sine 90 degrees plus theta. Yeah, let me deal with them like this. So we also have a cos 90 degrees minus theta, a cos 90 degrees plus theta. Okay, plus theta. Okay. I'll explain why this happens right after discussing the formulas themselves. Né? So for now, just bear with me. I have sine 90 degrees minus. Again, just like the reduction formulas, you check where this formula lies. Since it lies in the first quadrant and all ratios are positive, right? All ratios are positive. It means that it's going to be a plus cos theta. We say that cos is the co-function of sine, right? Or vice versa. Sine is the co-function of what? Of cos, right? If you have a formula, a co-function for sine, uma uyoyisolva, you should get a cos as your co-function, right? So again, we have this sine 90 degrees plus 90 degrees plus. This formula is found where? In the second quadrant. And in the second quadrant, sine is what? Is positive. So it's going to be a plus cos theta. You say sine, you change it to what? To a cosine, right? Because they are co-functions of each other. Don't worry, I'll explain this after explaining. I'll explain why a sine produces a cos and why a cos produces a sine, right? These functions are co-functions of each other. I'll explain. Just bear with me for now. So cos 90 minus theta. Where is this found? In the first quadrant. So in the first quadrant, cosine is positive, so it's going to be a plus. What is the co-function for cos? It's sine. So it's going to be a plus it's going to be a plus sine theta. Cos 90 degree plus theta. 90 degree plus theta, second quadrant, right? Second quadrant. And cos in the second quadrant is what? Is negative. So it's going to be a minus, since it's cos and we are dealing with a co-function. So the co-function for cos is what? It's sine. So it's going to be a minus sine theta. So this is how we deal with what? Co-functions. I'm going to take this down. Let me bring this here. Okay? Let me bring this here. But in the future, I'm also gonna create a video that discusses trigonometric functions, right? I'm gonna explain this in depth or in detail, right? The co-function. Once I've done that video, I'm also gonna link. I'm gonna leave a link in the description box. Just check it out as well. So for now, I'm just gonna give a brief discussion of the co-function. So we have a sine graph here. This is what we refer to as a sine graph. Let me also plot the cosine graph on the same system of axes. Okay, so we say that if or when you take the cosine graph in this sketch, right? In this sketch, if you take the cosine graph and then you shift it by 90 degrees to the right, it's gonna move like this, and as you can see, it's gonna align with the cosine graph, right? I mean, the cosine graph is gonna align with the sine graph. It means that they become equal. Once you take sine and move it to the right by 90 degrees, it aligns with the sine graph, or it becomes equal to the sine graph. That is why sine and cosine are co-functions. This is what we refer to as co-functions. They once you take one of these functions and move it to the left or to the right, they coexist. Yeah, they coexist. So I can also say, let's take sine and shift by 90 degrees to the left. Gonna do this. Do you see what happens? They coexist, or they become one. They become equal. They are co-functions, because once you take sine or cosine and move by 90 degrees to the left or to the right, they become one. But I'll elaborate further once I start discussing functions. So for now, this is just a teaser of what to expect for the co-function discussion. Just for now, what is important here is understanding the formulas. Okay, so let me just take this down. Let me also take this. No, take it down. Okay, let's take another set of examples. All right, so here I have a sine with a reflex angle, another reflex angle. Oops, but this is an acute angle, right? This is an acute angle. This is also an acute angle. But these acute angles are not, they are not what? They are not special angles, right? They are not special angles. But this, in this example again, we have to solve without using a calculator again, right? So this is also a reflex. So in order to solve these ratios, we have to reduce the angles to special angles. So let's go ahead and do that. So let me have the cast diagram on the side. So it's C cast diagram. So I have the reduction formulas, 180 plus, as well as 360 degrees minus theta. Okay, so we have sine, open bracket, 225. Where is this found? It's found in the third quadrant. It's found in the third quadrant. So here it's 0, 90 degrees, 180, 270, then 360. So 225, it's between 270 and 180. Here we go, 225. Okay, so 225, it's going to be written as 180 plus, I think it's 45, but let's check, minus 180, yes, 45, multiplied by cos, open bracket, 210, again, it's where? Third quad, so 210 minus 30, wait, yeah, it's 180, it's 30, man, yeah, it's 30 degrees, so it's 180 plus 30. You write or rewrite the 210 as a reduction formula, rewrite the 225 as a reduction formula, multiplied by sine 80 degrees. I'll explain this. There's something happening here between these two angles, right? I cannot find the value for sine 80 without a calculator. I cannot find the value for cos 10 without the use of a calculator, right? But I'll explain what's happening with these two angles. Let's just deal with the reduction formulas for now. So sine, cosine, it's cos 315. We find this in the fourth quadrant, so it's going to be 360. I think it's minus 45. Let's just check. 360 minus 315. Yeah, it's 45. It's 45 degrees multiplied by sine 240 again. Where is this found? In the third quadrant, so it's gonna be 180 plus 60, if I'm not mistaken. 240 minus 180, 60 degrees. So it's 180 plus 60 degrees multiplied by, okay, in a case where you see, in an instance where you see that the acute angles that are given, right, the acute angles that are given are not special angles, it means that between those two ratios you should be using co-functions, meaning that I'm gonna apply a co-function for the cos 10 degrees. You can also apply the the co-function on the sine 180 degrees. You choose one out of the two. So in this case, I'm going to choose the denominator. Okay. So here, I'm going to say, since 10 degrees is found where? In the first quadrant, right? In the first quadrant, we have a co-ratio of 90 minus theta. So here it's going to be a 90 degrees minus 80 degrees. 90 minus 80 gives us what? 10. 90 minus 80 gives us what? 10. Okay, gives us 10. So let's continue solving. This is equal to 180 plus, it's in the third quadrant, and sine is negative. Bracket. 180 plus cos is negative, so it's negative 30 degrees multiplied by, this doesn't change, remains as is, divided by cos 360 minus 45, so it's a plus cos 45 degrees multiplied by sine 180. 180 plus, it's in the third quadrant, sine is negative, so it's negative sine 60 multiplied by, so 180 minus, 90 minus 80. 90 minus 80. 90 minus 80, it's in the first quadrant, and it happens to be a reduction formula. So let's solve this. Cos is positive in the first quadrant, right? But since we are dealing with a co-function or a co-ratio, it means that this cos changes to a sine 80 degrees. Check this one. Now they are the same, so it means that this and this, they're gonna cancel, right? They're gonna cancel. So here I have a sine 45 using those two triangles, the ones I showed you on the previous slides, gives us a 1 over square root 2 multiplied by minus, you know what, let me just have them on the side. Why not? 30 degrees, 60 degrees, square root 3, 1, and then 2. So it's minus 30 degrees cos adjacent over hypotenuse. So it's square root 3 over 2 divided by cos. It's 1 over the square root of 2 multiplied by minus sine 60. 60 degrees, it's opposite over hypotenuse. So it's square root 3 over 2. Okay, this and this, they cancel. This and this gives us a, so a negative divided by a negative, it's a positive. A negative over a positive, it's a negative. So our answer is eventually negative 1. This over this 1, this over this 1, right? Minus, because this is the only sign that remains, negative. So the answer is negative 1. If you have any questions or If you have any questions, just leave them in the comment section of this video. I'll attend to them. Okay, so done and dusted. Let's take one last example. Let's take this one. Yeah, let's take this one. Maybe let me drag it to the left hand side. What am I doing? What am I doing? Let me drag it to this side. Yeah. Okay. Okay. Let's use the cast rule again. The cast diagram. Why am I using the cast diagram? It's because I have a reduction formula. I also have a reduction formula, but here I have a co-function, right? So it means the I need the cast diagram. So 180 minus, we know that it's in the second quadrant. So in the second quadrant, cos is negative. So it's going to be a minus cos x divided by tan. Tan is actually what? An identity. Remember, I did not show you. The co-function or the reduction form, the co-function or the co-ratio for tan. I've only shown you the co-ratio for sine and cosine. So it means that the tan I should actually write as sine 90 plus x over cos 90 plus x. So the tan I should write it as sine over cos multiplied by 180 plus x, third quadrant. In the third quadrant, sine is negative, like this, equal to, now let's work out what these co-ratios are. So on the numerator, it's still the negative cos x, and then sine 90 plus, it's a, so the 90 plus is what? Is the co-function. So 90 plus, it's in the second quadrant, and in the second quadrant sine is positive, so it's going to be a positive, but since it's a co-function, the sign changes to cos divided by cos 90 plus. 90 plus, it's in the second quadrant, cos is negative, so it's going to be a minus what? It's going to be a minus sine x multiplied by minus sine x. So this sign cancels that sign, because when I divide by 1, I am essentially multiplying two fractions here. So this sign cancels that sign, and this negative produces what? A positive. So I'm now left with a minus sine x, the one on the numerator, divided by a positive cos x, the one that remains after the sign cancel. So cos x over cos x, it's minus 1. Okay. Before I wrap up this lesson, I want to create just a quick summary. All right. So we learned about the cast diagram. We spoke about reduction formulae. Right? We spoke about the reduction formulae. So how many reduction formulas do we have? It's this, which is in the second quad. We also have this, which is also in the third quad. We also have this, which is in the fourth quad, right? These are the reduction formulas. These are used for reducing angles from obtuse or reflex to special angles, right? And then we also talked about co-functions. We only have two formulas. It's 90 minus theta, first quad. We also have 90 plus theta, second quad. Okay, so co-functions, it's where the sign changes to cos and vice versa. The cos changes to sine. Don't make the mistake of treating the reduction formulas as co-functions. Like after solving your formulas, then you change to the other function. No, no, no. It only applies to co-functions. Okay, I hope you enjoyed the lesson. Check the description box for links for other lessons that I've created for the trigonometry. So yeah, for now, I'll see you on the next one. Peace.